One of the things you're going to be taught in an algebra course is exponential functions and exponential equations. So you're looking at one right here. We write them out in the form of y equals ab to the power of x. Okay, so we have a table of values over here. These are numbers that you can choose from. Remember, your independent x values are your choice. Y is going to be dependent on what x is. So in an algebra course, you're going to learn how to graph these types of equations called exponential functions. You're going to need to be able to use them to make predictions for the future. You're going to need to be able to write your own exponential equations out. So let's break this down to make sure you have a good understanding of what an exponential equation is, how we use it, and what it would look like if we were to graph it out. So first and foremost, we need to understand what it is we're looking for, and that means that we're going to have an x as an exponent. That's different than a quadratic equation, which would have an exponent in it, but it would be a 2 right up there as your exponent, as opposed to the variable of x. So when the variable x is the exponent, you're dealing with what's called an exponential function, which means you're going to be rising very rapidly over time. So as you extend down the x-axis, it's going to start to curve and go rising. It's going to start to rise much, much quicker as you make your way down values of x. So let's learn about how we get the y values here. You do need to follow your order of operations. So if I'm trying to clean up the right side of this equation and simplify all of this down, step one is to plug the number in for x. This column is our x numbers. So 0 is going to go right in place of x. And then I like to just keep track of my work, put a 0 up there. Now, you may have already covered your exponent rules, but if you don't know what anything to the power of 0 is, you can always type this on a calculator and let it calculate it out for you. But 4 to the power of 0, we should know by now, is 1. Anything to the power of 0 produces a 1. 1 times 1/2 is going to give me 0.5 or 1/2. Now, why did I do this part first? PEMDAS, order of operations, tells us we have to do an exponent before we do any multiplication. 1/2 is being multiplied by 4, but because we have an exponent, this is the operation that gets done first, and then we finish by multiplying those two values at the end. So all I got to do now is just erase and replace. Instead of 0, now I'm going to be using 1. So 4 to the power of 1 is 4. Half of 4 is 2. So I'm going to take 2 and put it right there. Erase, erase, replace. Now I'm changing the x from 0 to 1. Now we're using 2. Well, 4 squared is 16, so we're going to get a 16 in there because 4 squared means 4 times itself. That gives me 16. Half of 16 is 8, so 8 goes down here. And last but not least, we need to erase and replace. 4 cubed is 64. Half of 64 is going to be 32. And last thing I want to talk about is when you are done with your table, you should have a pattern happening over here. If you look from 0.5 to 2, 2 to 8, 8 to 32, we are multiplying these by 4 times 4 times 4 times 4. And that will always match up with your b value in your equation. So 0.5 times 4 makes 2. 2 times 4 makes 8. 8 times 4 makes 32. You could then use that pattern to fill out the next couple of numbers very quickly as opposed to having to plug them in and simplify down. Okay, so one thing we need to understand, the b in y equals ab to the power of x, that right there is going to match with what's happening on the y side of your table. Okay? Now, when I go to graph this, I'm going from 0 to 3. So my x-axis is just going to look something like that. 0, 1, 2, 3. So why does it rise like it did, that curve that I showed? Well, we're going from 0.5 to 2 to 8, and then all of a sudden we just make this huge jump up to 32. So if I'm going from 0 to 32 on the y-axis, I'd probably need to go by like 5, 10, 15, 20, 25, 30, 35. So I could go and put, this is my 10, this is my 20, this is my 30. Now, if you look at how I graph these out, 0.5 is going to be really close to the x-axis. And then 1, 2 is 1 over, but it's only 2 up. That's barely even off the x-axis still. 2, 8, now we're starting to get away from the x-axis, but not much. And then 3, finally, this is when we have that big jump. We go all the way up to 32. This is just a quick sketch, but these are what these graphs are going to look like. They're going to curve up very, very quickly. They can also go down. That's if we have exponential decay, but what we're looking at here is an example of exponential growth. Okay, another thing we want to use exponential functions for is making predictions in the future. If you already know how a company's growing, or maybe you know how much value your car loses over a period of time. Okay, it's very common to see, like, you buy a vehicle and then you drive it off the lot. Every year that you drive that vehicle, you're going to lose about 15% of its original value. Okay, you can look this kind of stuff up on Carfax, and what we can do is we can then predict what we can sell our vehicle for down the road. So I'm going to give you an example real quick of an exponential growth versus an exponential decay function, and I'll show you how we can predict the future using that. Now, sometimes you're going to be given a rate. A prime example would be like if you purchase a vehicle, if you look on Carfax, they'll tell you that every year you own that vehicle, it's going to decrease its value by about 15% annually. So you'd be using a decay exponential function, which is 1 minus the rate. If we say 1 plus the rate, that would be growth. That would be something that increases in value over time. For example, baseball cards. Some baseball cards, the longer you hold on to them, the more they sell for. So you could say they grow at a rate of 5% annually. Okay, you can figure out what that card would be worth 20 years down the road if that trend continued. Now, let's use decay. So you buy a vehicle, it decreases in value about 15% each year. So 15% as a decimal is 0.15. That's the number you're going to be plugging in for R. So first thing we got to decide is, what did we pay for the car up front? Let's think of an initial value. That's our A. So let's say we bought a $21,000 vehicle. That's Y equals $21,000, our initial cost of the vehicle. It's going to be losing minus losing value. So we're going to take away the rate. Remember, the rate was losing at a 15% annual rate drop. So that's going to be 0.15. And we're going to put it to the power of X. Now, 1 minus 0.15, or 15 hundredths, that's going to leave me with 85 hundredths. We still have the power of X there. We still have our initial value in. But because we're taking a decimal to the power of something, this is going to make a really small decimal that needs to multiply by 21,000. And because it's a decimal, it's going to drop the value. So we originally paid 21,000 for this vehicle. Let's decide after 4 years, what's it going to be worth? So let's see what 4 years of driving a vehicle at 21,000 up front. So we're going to say 0.85. Remember, we need to do the exponent first. We're going to get a long decimal. Just keep that decimal in your calculator and hit times. Now it's just going to be multiplied by the original cost. 21,000. We got about 10,900 and what's that say? 62. So that vehicle that was 21,000, you can now only sell for somewhere around 10,962. This is an approximation. Now keep in mind, some people do a really good job of taking care of their vehicles. You could probably bump that price up to 13 grand if you're someone who has a pristine used car 4 years later. You never let a kid eat in the back. You always wash that thing when you go on a dirty drive and like the snow's out and you got gunk on the side of the car, you wash that off right away. Okay, you take care of your car. 3,000 miles, time for an oil change, baby. You could probably increase this price. This is like an average. Now, if you're somebody who doesn't take very good care of your car, you get a rock chip on the windshield and you let it crack goes farther and farther up the windshield. You never take it in to get an oil change until you start seeing smoke. You're probably not selling it for $10,962. You're probably going to have to drop your price because there's going to be some issues with that vehicle, more likely than to the person that took good care of it. But most of us, we're going to end up right around in that general area. You have a little bit of wiggle room. 10,000, maybe 9,000, 11,000, those are going to be your options. But again, keep in mind, there's some of us out there that do a really good job of taking care of our stuff. You could probably get 14 grand out of that if it's in pristine condition 4 years later. Okay, that's how you would make a prediction for something in the future based off of the rates that you've seen so far. Hopefully this makes sense. Study hard and good luck on your upcoming test.